Okay, hey, welcome to Michigan. It's fall, as you can see. I'm gonna jump in the car and show you how standstill detection works. Bear with me. Now, as you can see here, I'm just gonna use the ADMA speed, and I'm gonna use the single unit IMU antenna. So this is our MEMS-based unit. This would be like the ADMA Slim as well. Now, because the IMU and antenna on this unit are built into one, it's pretty easy to do the setup for the offsets. Okay, so here I am where it's nice and warm. Give me a couple minutes just to turn on my PC here, connect it using Ethernet, and then I'm going to use a web browser, like I'll probably just use Google Chrome to do the setup, and then use the Ethernet logger to just make sure we have enough satellites, check the signal integrity, show you the standstill detection, and I'll try to show you initialization. So it may be a little crazy. Here we go. Now what you see here is the web interface. It loaded up right out of the ADMA, and we're just gonna go from left to right if we wanna do a setup. This unit's already set up. The vehicle's already set up. Not much to do here except run, do our initialization. So if you did want to do a setup, this is where it would be, and this is where you could load and save and do all that kind of stuff. So now we can just run the actual Ethernet logger. Okay, so now Ethernet logger, we'll open this up, because this is a great tool to use for setup, checking the number of satellites, troubleshooting if you need to, but it just gives you a very quick understanding of where you are in the initialization process and where the unit is. So right now it's already loaded and receiving data, but if I wanted to, if I made changes, I could easily just load the settings from the ADMA of the changes that we had made. Then we just go to measure mode. And then in measure mode, we have some different panels available. And these are the panels we're going to be looking at here when we get ready to do the initialization. Right now, it's looking for us just to be sitting here, and it's waiting for the pre-initialization. Now when it turned green, this is where I would do my initial straight line run. And then after that, we would just do some figure eights or some maneuvers until these three bars get to 100%. In actuality, if you're on the proving grounds, they only need to be above 70. But you can see the different information that's available. You can see things like how many satellites we have, whether we're using RTK. Yaw angle is one we'll be looking at here in a minute. So if you look at yaw, pitch, roll, and yaw right in the middle of the screen, it shows 360 because we've not been initialized. So once we start driving around, you'll see we'll do some figure eights, and then I'll try to show these panels while I'm driving with my phone here. Okay, so we're ready to initialize. We've told the system prior that we need to be above 5 meters per second to start the initialization here in the straight line. So right now the yaw is not correct until we do this initial straight line. So here it's ready for us. So I'm in drive. Here we go. Let's go really fast here. Fast as I can. And then I like to come to a nice hard stop. And now, checking the yaw, we can see we're exactly on the yaw. Now remember, this is a MEMS-based unit, so we have a little bit more yaw drift than we would with our fiber optic gyros. But you can also see the standstill detection. So right now we're not moving at all. And as soon as I give it just the slightest movement, you'll see that standstill. Slightest movement. I mean, I can't even rock. So right now it thinks it stands still. If I just move the car by rocking it right now, it thought we were moving. So I'm just barely rocking it. You can see it toggling. So it's very sensitive, and you can control that sensitivity. Okay, so we're back now. And I just started that little maneuver. We didn't actually fully initialize the Kalman filters here, but you can see we have a very steady set of numbers, yaw being one of the ones that matter the most. Here we are and standstill, even with our lowest end unit, a very stable yaw measurement.